Here are solutions to homework set number 3 for ECE 111, Introduction to ECE. This homework set looks at using Matlab to solve problems that you'll encounter when you take trigonometry, basically sines, cosines, unit circles, stuff like that. The first problem is, suppose I have three vectors in polar form. What is the sum of those three vectors? And what that means physically is if I am walking, I go 16 miles at 35 degrees. Here's x and y. I then go 6 miles at 81 degrees, then 1 mile at minus 11 degrees. Where do I wind up? Well, in Cartesian coordinates, the x's add and y's add, so one trick is to convert to Cartesian. In polar form, r at angle theta, the x value is our cosine theta, the y value is our sine theta. So calculate the x and y value for each point, noting that Matlab uses radians, so I have to convert degrees to radians for this to work in Matlab. There's your first point, second point, third point. Add them all up. Here's the x and y coordinate. Kind of a sidelight. This is actually really easy to do with an HP42 calculator. One of the calculators I really push. It, in my opinion, is worth 10 points on tests. This is a free app on your cell phone, and I kind of like free. So to get used to HPs, they are a little bit weird. I would use the free app. To do that, I would input, the first one is 16 at 35 degrees. So let's go modes, polar. I'll then do 16, enter 35. That puts it on the stack, and then complex. Inputs that number, 16 at 35 degrees. Now take 6, enter 81, complex. 6 at 81 degrees, add the two together. The x's add, the y's add. Where I wind up is at 20 at 47 degrees. Now add 1 at negative 11 degrees. Add that, and there's my final spot. To see what it is xy, just do modes rectangular, and there's the x coordinate and y coordinate. So the calculator is actually easier than Matlab for this type of calculation. Number 2, add these vectors together. In Matlab, I'd find the x and y coordinate for each point, add up the x's, add up the y's. On an HP calculator, I would say, let's go back to polar form. 8, enter 48, complex. 16, enter negative 56, complex. Add those together. 10 at minus 10. Add those together. There's the final spot. In rectangular coordinates, it's 24x minus 9y. Problem 3 is, where is b relative to a? So this is b, this is a. If I take the difference, I got a sign error. I did a minus b, so that's why I do the sign flip. Point B is 9 meters to the right, 23 meters down. If I want to look at it in polar form, it's 25 meters away at minus 69 degrees. So graphically, here is the point A, here's the point B. It is 9 meters to the right, 23 meters down. That's the Cartesian coordinates, where polar coordinates is 25 meters at minus 69 degrees. Problem 4 is plotting polar functions. Now polar functions, actually, sine and cosine are all about the unit circle. If I do something like this, the radius is 5 sine theta minus 2 cosine theta, for theta going from minus 2 pi to plus 2 pi. This is what I get. I'll take angle from minus 2 pi to plus 2 pi, steps of 0.01. Step size is kind of arbitrary. More than 2, less than a million points. R is, just like you type it, 5 sine theta minus 2 cosine theta. In Matlab, plotting is always in Cartesian coordinates, so the x value is our cosine theta, the y value is our sine theta, and note, I had to use the dot notation. This tells Matlab that don't treat these as two matrices, treat those as just a bunch of numbers, do it element by element. The result is, surprise, surprise, a unit circle. Another polar function. If I have this one, r is cosine 2 theta plus 0.5 cosine 3 theta. Here's angle, here's the radius. Find the x-coordinate, find the y-coordinate, and you get, kind of a funky four-leaf clover. Do this function, sine plus 1/3 sine 3 theta plus 1/5 sine 5 theta plus 1/7 sine 7 theta. Pull out the x and y coordinate, I get something that looks like a frog. Problem 5. Suppose I have a robotic arm. This is 0 degrees in the x direction and y. I've got the first link is 2 meters. The second link is 1 meter. Third link is 1 meter. I specify the joint angles. That'd be your theta 1, theta 2, theta 3. The position of each point, this is your x1, here's your x2, point 2, here's your point 3, x and y. Given the joint angles, where's the tip position? That's called forward kinematics. That's actually pretty straightforward. Given theta 1, theta 2, theta 3, I just grind out, here's the first point, xy. The second point is the first point plus the xy location of this joint. The third one is position of the previous link plus the xy coordinate of this link. In Matlab, what do I do? If I have the angles 26 degrees, 38 degrees, 46 degrees, first convert to radians. Here's the base is at the origin. The first link, its xy coordinate. The second link is wherever the first link was plus its xy coordinate. The third link is wherever the second link was plus its xy coordinate. X3, Y3 is the tip position. So this is one way to do it. I can also create a function in Matlab. So here's the function called RRR. I pass it the 3 angles, converts to radians, calculates the positions, and then plots it. What that does is if I try to run this, I'll get an error message. What I really did is I just changed the path. When I save this, I have to save it as rrr.m. So in the command window, I can now call it, say rrr 10 degrees, 20 degrees, 30 degrees. Oops. Well, it's just 3 numbers. 10 degrees, 20 degrees, 30 degrees. It then calculates, here's the base, the first link, second link, third link. Or, if I want to go at 26 degrees, 38 degrees, 46 degrees, and return 2 parameters. It tells me here's the x-coordinate, there's the y-coordinate. So x is at 1.8, y is at 2.71. If I pick different angles, like let's do RRR of minus 40 degrees, 32 degrees, 28 degrees. There's the tip at 2.7. Oops. Return 2 parameters, x3, y3. The x-coordinate is at 3.46. The y-coordinate is at minus 1.0. That's forward kinematics. The harder one is going backwards. If I specify the tip position, like here's where I want the tip to be, what angles put you there? So that's actually pretty hard to solve. Going forward, let's go back a little bit. I just take the angles, calculate x3, y3. Going backwards, given x3, y3, what are the joint angles? That's actually really hard to solve. This is where a function called fmsearch is really useful in Matlab. What I will do is, here's my function, RRR. The point that I'm looking for is x is 1, y is 2. So just for fun, there's my target position. And what I'm trying to do is find out what angles push the tip right here at 1, 2. So what I can do is guess again, guess again. Let's try 60 degrees, 70 degrees. Yeah, better, still not quite there. Guess again, or let MATLAB guess for you. Now in MATLAB, you can have functions called functions. Here's a new function called problem 7. I'm going to pass my guess, that's your theta 1, theta 2, theta 3, in an array. fmsearch that we're going to be using wants just a single parameter. It could be a matrix. So in this case, this is parsing it. What z means is the first angle, second angle, third angle. I'll calculate the tip position, given those angles. Then how far is x from 1? How far is y from 2? Return the distance to my target. Drive the error to 0. So that's problem 7. If I try that, problem 7, and here's my guess, 10, 20, 30 degrees. I'm off by 2.17 meters. Let's try 10, 50, 60. A little bit better. Keep guessing until I drive the error to 0. So what I'll do is, instead of calling it, I'm going to call fmsearch. So z is my answer, e is the error, that should be 0. Call fmsearch. That's the Matlab function that tries to find the minimum of a function. The function I want to minimize is problem 7, and here's my first guess. Let's go. Let's go. And it's iterating, trying to drive the tip to there, trying to drive the error to 0. And guesses. Looks like it found the answer. Answer found is, here's theta 1, theta 2, theta 3. Now note the answers are not unique if I give it a different initial guess. So here's my first guess. It's going to take that initial guess, try to drive the error to 0. Looks like it found it. Another valid solution. So in this case, this actually has an infinite number of solutions. fmsearch, all it's trying to do is find a solution. So here's theta 1, theta 2, theta 3. Here's the error in the tip position. Basically nailed it. fmsearch is a really useful function. If you can take your function and convert it to a minimum, fmsearch can usually solve. So here what I did is found the distance to my target, find the error, and then return the distance. The sum squared error, square root gives it distance, and it'll try to minimize the distance to that point. So that is homework set number 3 for ECE 111 using trig functions in Matlab. It's all about the unit circle, and where trig functions really shine is with robotics. I specify the joint angles for a robot, and I want to know where are the joints. That's homework set number 3 for ECE 111.